So the big picture for this lesson is nth roots and rational exponents. So what is an nth root? We have square roots and we have cube roots, and the roots keep going, so you can have a fourth root. Fourth root of 16 equals 2, for example, because 2 to the fourth equals 16. And you could have any possible whole number for an index, which means that is the root. So the 4 here is the index of the radical. So an nth root means any radical. Then there's rational exponents. Rational exponents allow for different combinations of powers and roots. Simple example, x to the 1/2 is a square root. X to the 1/3 is a cube root. What about x to the 2/3? That is the cube root of x and then squared. So it's like the numerator is the power and the denominator is the root. That's probably the simplest way to work with these. Do the root first and then do the power second. So for example, 4 to the 3/2 power, that equals the square root of 4 to the 3rd power. So the square root of 4 is 2, so it's 2 to the 3rd, which is 8. How about 16 to the negative 3/4? That equals, remember that the negative exponent means a reciprocal, so it's going to be 1 over the 4th root of 16 and then to the 3rd power. So the 4th root of 16 is 2. We already established that, so it's 1 over 2 to the 3rd power, which is 1/8. So that's what rational exponents are all about. And you're going to see examples in the lesson of doing this type of work that I just showed you, and also using a calculator to find decimal answers for different types of roots and rational exponents. And also you're going to use roots and rational exponents to solve equations, and there are examples of that in the lesson. I would like to take a minute and explain these different properties for nth roots. So n has to be a whole number greater than 1, or a positive integer greater than 1, and let a be a real number. If n is odd, then a has exactly one real nth root. If n is even, then a has 2 real nth roots. And if n is even and a is to the 0, then you just have 0 to whatever equals 0. And then if n is even and a is less than 0, there are no real nth roots. So these are all used when solving equations. So for example, let's say you have x to the 6th power equals, I don't know, 100. Well, to solve this, we'll actually do the 6th root of both sides. But because 6 is even, then there are going to be 2 possible solutions. X equals plus or minus the 6th root of 100. But if you have x to the 5th equals 100, solve by taking the 5th root of both sides, x equals the 5th root of 100. So there's only one solution if your index is odd, but there are 2 solutions if it is even. And for the a is less than 0, well, what if you were doing x to the 6 equals negative 100? Well, if you take the 6th root of that, well, there's no real solution for this. There's imaginary solutions, imaginary numbers, but not real numbers. But if you were taking the 5th root of negative 100, the 5th root of negative 100 is a real number. So you're taking roots of negative numbers. If it's an odd root, you have a real number solution. And if it's an even root, then you have 2 imaginary solutions. So that's the big picture.